Thanks for clicking on this video. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. Now today we're talking about finding the volume on the base where the cross sections are triangles. Now if you haven't watched the video where I find volume on base with squares and rectangles, go pause this video and go watch that. And I'm linking it up in the upper left hand corner and down in the description below, because some of what we do here is going to be dependent on you having watched that. So make sure you watch that and then come back and watch this one. So with number 1, we have the region x squared plus y squared equals 1. So here is our base from -1 to 1, and from 1 to -1 this way. Now, as we said in the previous video, our slice, our cross-section, goes this way. And so this thickness is dx, and the length here is 2 square root of 1 minus x squared. And now, what we want to do is now say, okay, if we have a triangle, what does this triangle look like? Well, we know that this length is 2 square root of 1 minus x squared. Now we know that the height is double that. So the height is 4 square root of 1 minus x squared. So if I want to draw a few triangles, that's what they look like. Sometimes people find it difficult looking at this like this, with 2 dimensions, when we're trying to represent a 3D shape where these slices should actually be sticking out from the page. And so oftentimes what people will do is they will draw off to the side a separate representation of each slice. So the volume of this slice, okay, so it's a triangle, so 1/2 the base, so 2 square root of 1 minus x squared times the height, 4 square root of 1 minus x squared, and since this is a 3-dimensional slice, it has a thickness, dx. And that's going to simplify to just 4 when I multiply the 1/2, the 2, and the 4. And so when I find the total volume, I'm going to add up the volume of all the slices from -1 to 1. And I'm going to put the 4 out front. And so that's square root of 1 minus x squared squared dx. So you can simplify that to say 1 minus x squared dx like that. Now letter B, here we have a right triangle, and it's a 30, 60, 90 right triangle whose long leg is on the base. So here's my region again. And so this right here is the long leg of a 30, 60, 90 right triangle. So if I draw this off to the side, here's 30, here's 60, and there's 90. Now this is 2 square root of 1 minus x squared. And so to go from the long leg to the short leg, I have to divide by square root of 3. So it's 2 over square root of 3 times 1 minus x squared. And if I rationalize that, that's going to be 2 square root of 3 over 3 square root of 1 minus x squared. So the volume of this slice is going to equal, it's still a triangle, so 1/2, I treat this as my base, 2 square root of 1 minus x squared times the height, 2 square root of 3 over 3 square root of 1 minus x squared dx. So the 2 and the 1/2 will cancel out. So I take the integral from -1 to 1. This coefficient I'm going to put out front. 2 square root of 3 over 3. That goes out front here. And then we have square root of 1 minus x squared dx. So we can simplify that to 1 minus x squared dx. So there is our expression for that volume. Right. So on the next page, for the second example, we have the region between x squared and 2 minus x squared. So if I draw that, it looks like this. So there's x squared, and there's 2 minus x squared, and this is -1, and this is 1 where they meet. Now on the previous video, we said that this is our slice, and this is the thickness of dx, and that right there has a length of 2 minus 2x squared. Now this is an equilateral triangle as it sits up above. So if I draw that equilateral triangle like that, each side is 2 minus 2x squared. 2 minus 2x squared. But what I'm going to do is I'm going to divide this into 2 halves. Now it doesn't look like a half. I had trouble drawing that, but we'll make do. And so 1 minus x squared, 1 minus x squared. Now when you draw an equilateral triangle and cut it in half, it breaks it into a 30, 60, 90 triangle. And so this height is the long leg of a 30, 60, 90 triangle. So this height is square root of 3 times 1 minus x squared. So we've got our base, 2 minus 2x squared, and now we've got our height. And so the volume of the slice is, it's a triangle, so 1/2 the base, and I'm going to write it as 2 times 1 minus x squared, because the 2's will cancel out. And because if I include the height, I can multiply these two together. And it's a thickness of dx. So now, when I write the integral, it's going to be from -1 to 1 because I'm adding up all these slices. The 1/2 and the 2 cancel out. The square root of 3 goes out front. And we have 1 minus x squared dx. And do you have to simplify it any more than that? No, you can leave it just like that. Letter B. Here we have a 45, 45, 90 triangle whose hypotenuse is on the base. So I don't need to draw the region at this point. I really just need to draw the slice and say that, all right, well, this is 2 minus 2x squared. That right there is the part that's on the base. So now, if I want to figure out these two lengths, I have to divide these by square root of 2. So 2 over square root of 2 minus 2 over square root of 2 x squared. And if I rationalize that, I get 2 square root of 2 over 2 minus 2 square root of 2 over 2 x squared. So I get square root of 2 minus square root of 2 x squared. And I can factor out a square root of 2. And so that's this length, and so it's also this length. Now in a right triangle, you can always use the 2 legs as the base and the height because they are perpendicular. Because I can always turn this triangle around to make it look like that. So the volume of this slice is 1/2. It is a triangle, so 1/2 the base, square root of 2 times 1 minus x squared times square root of 2 times 1 minus x squared dx, because we have a thickness. Now, square root of 2 times square root of 2 is 2, which is going to cancel out the 1/2. So there's going to be no coefficient out front. It's just going to be 1 minus x squared dx. That is our integral. For number 3, here we have the region of y equals 2 square root of sine of x. And it goes from 0 to pi. And so our slice is right here with a thickness of dx and a height of 2 square root of sine x. And we've got an equilateral triangle. Now we said that the sides are 2 square root of sine x, 2 square root of sine x. So now, like I did in the previous problem, I'm going to break up this base into 2 equal halves, square root of sine x and square root of sine x. And so now the height, to get the height, remember that this is a 30, 60, 90 triangle. So I multiply this by square root of 3. So square root of 3 times square root of sine x. And I'm not putting the 3 inside the sine x because it's going to, that's just a coefficient. It's going to go out front anyway. So to find the volume of the slice, we have 1/2 the base. So that's 2 square root of sine x times the height, square root of 3 times the square root of sine x dx. So the 2 and the 1/2 cancel out. The square root of 3 will come out. And the square root of sine x's also cancel each other out. Well, sorry, they don't cancel each other out, but they allow the square root to go away. So we have square root of sine x squared dx, which we can just write as square root of sine x dx. Now letter B, a 45, 45, 90 right triangle whose leg is on the base. Now this one is nice because we have 2 square root of sine x for right here, and so that is also this, 2 square root of sine x. So that serves as our base, and that serves as our height. So we have 1/2 the base, 2 square root of sine x times the height, 2 square root of dx. The 2 and the 1/2 cancel out, but there's still another 2. Remember that multiplying doesn't distribute. Multiplying distributes when there's addition. So there's another 2 out front, sine of x dx, because the 2 square roots, when you multiply, just result in sine of x. All right. Now in the last problem, here this one, if you remember from the previous video, we've got this region. So that goes all the way up to 16 up there. But here the slices are perpendicular to the y-axis, like this. So the thickness is dy. And the length, as we said in the previous video, is 2 minus the cube root of y over 2. Because since the thickness is dy, everything has to be in terms of y. We have to use y. Just like in the previous 3, they were all dx for their thickness. So everything had to be in terms of x. So, letter A, the triangles whose height is half the length of the base. So the base is 2 minus the cube root of y over 2. Now the height is going to be half of that. So the height is going to be 1/2 times 2 minus the cube root of y over 2. I'm just going to leave it like that so we can combine these. So the volume of the slice equals 1/2 the base, 2 minus the cube root of y over 2 times the height. So 1/2 times 2 minus the cube root of y over 2 dy. So the 1/2s will combine to become 1/4. 0 to 2. Nope, this is dy. So it's 0 to 16. And so these two will just be that quantity squared. There. Now with letter B, we have a 30, 60, 90 triangle whose hypotenuse is on the base. So the hypotenuse is 2 minus the cube root of y over 2. And so this is 60 and this is 30. So to go from the hypotenuse to the short side, we multiply by 1/2. So that's 2 minus the cube root of y over 2. And to go from the short leg to the long leg, we multiply that by square root of 3. So that's square root of 3 over 2. 2 minus the cube root of y over 2. So again, when we have a right triangle, treat the two legs as the two sides. So the volume of the slice is 1/2 the base. So I'm going to treat that as the base. 1/2 times 2 minus the cube root of y over 2 times the height. So that's square root of 3 over 2 times 2 minus the cube root of y over 2 times dy. So now we multiply these three. And so we get 1/2 times 1/2 times square root of 3 over 2. So that's square root of 3 over 8. We get 0 to 16. And then we have 2 minus the cube root of y over 2 squared dy. And there's our integral. Thanks for watching. If you like this video, hit that like button. And if you want to see more, click the subscribe button. To support the channel, click the links in the description down below. Thanks for watching. And remember, the best way to understand something is to do it.